Hello everyone. My name is Tejas. I'm Principal Program Manager for SQL Server Product Group. Welcome to Data Platform Summit 2020. Today, I'm going to talk about SQL Server on Linux in Azure ecosystem. I have a fairly packed agenda, so I'm going to keep the agenda fairly tight. I'm going to introduce SQL Server on Linux ecosystem and some of the basic SQL Server 2019 improvement themes. I'll talk about SQL Server on Linux images in Azure Marketplace and some other deployment strategies. I'll talk about performance tuning of SQL Server on Linux in Azure ecosystem. I'll also talk about high availability alternatives for SQL Server on Linux in Azure ecosystem. And then I'll just summarize before closing the session. And through the time period, I am available on chat for Q&A as well. So please feel free to IM me with any of your questions. So SQL Server on Linux was introduced in year 2017 with SQL Server 2017. SQL Server is currently available for production support on Red Hat Enterprise Linux, SUSE Enterprise Linux, and Ubuntu. SQL Server on Linux can also be deployed as containers on either standalone machines or different orchestration platforms, such as Kubernetes or Red Hat OpenShift, including the managed Kubernetes alternatives, such as EKS or Azure Red Hat OpenShift. One of the things when we released SQL Server on Linux was to ensure that we also provide certain Linux native experiences, such as the installation experience for SQL Server on Linux is based on the packages, which is the standard native installation mechanism for SQL Server on Linux. Of course, SQL Server remains available on Windows Server as a platform. And one of the most important thing to understand about all of this is that we provide a complete database compatibility across all the platforms. What I mean by that is that you can take a backup of a database running on SQL Server on Windows platform, restore it on a SQL Server running on Linux platform, or even on a container, and run the same query, and it would not only give you the same result, it would perform pretty much the same way, including the same execution plan, provided all the resources remain same. The way we did this is by a component called platform abstraction layer, or what we call SQL PAL. It's based on a project by Microsoft Research called Drawbridge. It allows us to run a Windows binary on Linux platform, which means that we are actually running the same binary for SQL Server on when we are running it on Windows as a platform, or Linux, or even container as a platform, which allows us this great compatibility story across all the platforms. Now, let's talk a little bit about SQL Server 2019. I mentioned we introduced SQL Server on Linux with SQL Server 2017. Let's just briefly talk about SQL Server 2019. So SQL Server 2019 introduces certain solutions for modern, what we call modern data challenges. One of the one of the most modern data challenge is the heterogeneous data sources that any corporations have in their ecosystem, which includes the NoSQL data as well as big data architectures. And SQL Server 2019 introduces a recreated feature called Polybase, which allows heterogeneous data access across data sources, including relational data sources, and NoSQL, and big data sources. Of course, we also continue to adopt with modern data platforms, as I was talking about. And then we also introduced new capability for built-in language support for Java with SQL Server 2019. So now SQL Server can use the language extensibility capability to call R code, Python code, or Java code for extended machine learning and artificial intelligence code, including extending the T-SQL language with additional functionality. Of course, we have continued to improve and focus upon our performance tuning improvement, and we have invested heavily on the intelligent query processing umbrella. And another improvement which is new in SQL Server 2019 is the accelerated database recovery, which allows us to recover database faster and roll back transactions quicker, providing higher availability to most in most cases. Now let's talk about SQL Server 2019 on Linux specifically. Now, when we introduced SQL Server on Linux back in SQL Server 2017, we had certain functional parity gaps. And we listened to our customer, and customer provided us fairly vocal feedback. So SQL Server 2019 addresses quite a few of the parity gaps. For example, SQL Server 2019 has a replication and CDC or change data capture functionality available now. SQL Server 2019 on Linux also introduces machine learning services with R and Python code, what we just talked about, as well as language extensibility with Java as a language. SQL Server 2019 on Linux also introduces poly-based functionality. SQL Server 2019 on Linux also introduces a certain additional hardware enablement, such as persistent memory enablement, which is becoming fairly ubiquitous in enterprise deployment. Of course, SQL Server 2019 also introduced support for many of the new version of the supported distributions, such as RHEL 8 and Ubuntu 18.04, and also Red Hat-based container image, as well as non-root containers for better security support. So while we were working on, while we were talking about SQL Server 2019 on Linux improvements, also focused upon ensuring that when you want to use or when you are considering SQL Server on Linux as a platform in Azure, you have a good experience in terms of deployment as well. With that in mind, we have ensured that appropriate images for latest distribution and a combination of latest version of SQL Server and the latest distribution support are also available in Azure Marketplace. For example, I have highlighted over here that you have SQL Server 2019 on Ubuntu 18.04 or Red Hat Enterprise Linux 8 or /12 SP5 images which are available in Azure Marketplace today. Now, I wanted to highlight this very specifically because it's actually quite important to understand. These images being available in Azure Marketplace actually gives you very good experience in terms of the deployment. It gives you agility of deployment and flexibility of deployment as well. And what I mean by that is it allows you to deploy SQL Server on Linux in Azure ecosystem very, very quickly. Just to give you an example, I was just doing a deployment of a 4-core 32 GB machine, which is standard E4v3 size. And I also, here is the combination of the OS and SQL Server version, which is SQL Server 2019 on RHEL 8. And as you can see, in under 2.5 minutes, I was able to deploy a fully functional SQL Server 2019 on RHEL 8 machine with four cores and 32 GB RAM. And you have to remember that the core and the RAM is relatively nominal part of the discussion. Even if you were to deploy a 32 core machine, it should the deployment time remains nearly identical. So as you can see, you can very quickly deploy SQL Server on Linux in Azure ecosystem according to your requirements in terms of both hardware and software combinations. Of course, another alternative to deploy SQL Server on Linux remains some sort of a shell script. So you can deploy SQL Server, you can deploy a Linux image in Azure ecosystem and run a post-deployment shell script which can do the installation of SQL Server in an unattended fashion on your behalf. And let me show you an example of that. Another good alternative for quick installation for SQL Server on Linux remains shell scripts, or the use of shell scripts. For example, in this example shell scripts, I am configuring the repositories and running the installation steps. Additionally, I'm also doing certain post-configuration installation, such as configuring the appropriate environment variables for SQL Server tools as well, and necessary the firewall configuration. And this kind of shell script can be extremely efficient for SQL Server deployment in Linux ecosystem. For example, I executed this particular shell script on a new Ubuntu installation in Azure. And if you can see from the start time being 11:59:06 and the end time for the installation being the 12 o'clock, basically in just over a minute, I was able to install a SQL Server package and do necessary custom configuration, including installation of SQL Server tools. Now, you also have to remember that this does not include the deployment of the VM itself. And considering you can get quicker deployment with the marketplace images, I would still highly recommend use of the marketplace images for your deployment. But I just wanted to provide you the second alternative in case you are interested in doing custom configuration and custom deployments. Now that we have talked about choosing the right image, which is basically a combination of the SQL Server version and the operating system version, let's talk about how you should plan for your deployment of SQL Server Linux in Azure ecosystem. So after choosing the image, which is basically your SQL Server and Linux version combination, the next thing on the agenda typically is choosing the right VM size. Now that we know that there are a lot of different VM sizes available on Azure as a platform, and quite a few of them are for general purpose use. And we wanted to help you choose the right kind of VM images. So we did an analysis of all the VMs deployed on Azure platform, which are used to host SQL Server databases. And we basically chose some of the most commonly used the VM sizes used to deploy SQL Server workload. We essentially chose 4 images on 3 different t-shirt sizes, large, medium, and small. The large VM sizes are 128 core and higher. The medium VM sizes are basically higher than 32 core, but less than 128 core. And the small VM sizes are all the VMs up to 32 cores. And we basically have highlighted some of the VMs which are most commonly used for SQL Server workload. And the reason why these VM sizes tend to be used most frequently for SQL Server workload is that actually the ratio of CPU to memory available on these VM sizes. SQL Server being not only a compute, but also memory-hungry application, which improves the performance of the database. Obviously, the more database pages that can reside in memory, better the performance. So the higher CPU or core to memory ratio tends to be more preferred. And we have listed out some of the VM sizes over here, which are which are popular choices on 3 different t-shirt sizes, as I said, large, medium, and small sizes. So now that we have basically chosen the image type, which is basically a combination of SQL Server and operating system and the VM size. Now let's talk what should be on your next on your agenda for highly performing deployment of SQL Server. Now, typically the next most important topic of consideration is storage. Now, the way you should go about it is you should consider all the required IOPS for your database workload and any other workload that may be hosted on the database VM. And you should actually consider this in both storage and VM configuration. Now, we just saw And if I go back, just a second, every VM size has actually an upper limit on number of IOPS that can be performed. So when you are choosing your storage configuration for your VM deployment, you should consider the VM size that can provide you with appropriate IOPS, as well as you should choose the storage which can support your required IOPS. For example, if you need certain number of IOPS, let's say 30,000 IOPS, you could choose, let's say, P30 disks, which have 5,000 IOPS, and you could select basically multiple of this P30 disks, let's say 6 disks, to get the required IOPS. Essentially, you should essentially plan for your IOPS and your storage requirement when you are planning your SQL Server deployment. Now let's say you have already considered all your storage requirement, and you have allocated the appropriate number of managed disks to get the required IOPS, and you have chosen the right VM configuration to get the required IOPS. The next thing typically you would want to do is create some sort of a software RAID, which would be sort of an equivalent of a storage pool in Windows ecosystem. And software RAID is the Linux equivalent of that. And you should probably consider using software RAID deployment across multiple of these managed disks to get the required IOPS for your deployment. And in case of Linux, you could choose something like MDADM to configure the software RAID configuration. Of course, when you are doing some sort of a software RAID deployment, you should make sure that you have the appropriate alignment of the stripe size and the block size to support your configuration. Now, just to show an example of what this kind of a configuration would look like, this is an example of this. So in this case, for the log drive, I have created basically a stripe, basically a software RAID across 4 devices, and basically it's striped across 4 devices with 64 KB stripes. And it's a RAID 10 configuration. For the data drive, I've chosen 9 devices in this case to get the appropriate required IOPS in a RAID 5 configuration. And in this case, the software stripe is essentially 8K stripe. And for the 10th DB, I've chosen 6 devices in this case. And it's once again in a RAID 10 configuration with a 64K stripe. And this is the kind of configuration I made in this case based upon the kind of IOPS requirement I had for the test configuration that I was trying to deploy. So this is an example configuration that you should consider. Basically, you should consider your configuration in similar manner when you are trying to deploy your storage configuration to support your IOPS requirement. Now that we have talked about the storage configuration per se, what is the next thing on the topic? Now, the first thing to do after you basically allocate all the storage is to essentially format it. In case of Linux ecosystem, we support 2 different file systems, which is an ext4 file system. We actually prefer XFS file system because there is continued investment, including performance and functional improvement in the XFS file system ecosystem, versus ext4, which seems to be more in the supported state, obviously, but it's still, it's essentially in the maintained state rather than in an improving state. And we have been working with our Linux partners, namely Red Hat, SUSE, and Canonical. And the general consensus is that XFS is the preferred file system for deploying SQL Server workload. Now, after you have configured your storage, the next thing what you should do is essentially configure your SQL Server correctly to be able to use appropriate storage configuration. Now, one of the thing is this FUA configuration specifically for SQL Server on Linux. Now, there is a blog link that I have mentioned over here, and I'm not going to go into too much detail, but FUA is one of those functionality that allows SQL Server to flush specific I/O to devices without impacting the I/O across whole device. FUA capability essentially allows us to provide the vault or write-ahead logging protocol, which is essentially required for the reliability of any database engine. Now, when we introduced SQL Server in Linux ecosystem, what we found was that the FUA capability for I/O against devices was not available in user mode ecosystem. So the SQL Server product group worked with our partners in Linux ecosystem, with both SUSE and the Red Hat partners, and we work with them to bring the FUA capability in the Linux ecosystem. This FUA capability was introduced only on the XFS file system, which is another one of the reasons why XFS file system is a preferred deployment or file system for SQL Server deployment in Linux ecosystem. And you should, take a look at some of the versions of the operating system which support this FUA capability. So today, RHEL 8.x versions and /12 SP5 have proper FUA support in user mode, which means you can configure SQL Server to use this FUA functionality correctly without any performance overhead. We are working with our canonical partner to enable FUA support in Ubuntu 18.04 and possibly even 16.04. And the same blog actually has some alternative configuration for FUA to get some level of performance if the file system does not support FUA capability. The way to think about this is that if you are using XFS file system, and if the operating system supports FUA capability, and if the underlying device also supports FUA capability, then you should use the configuration that I have mentioned over here, which is tracelet 3979 and a couple of MS SQL conf options, which are write through and alternate write through appropriately. And you can get the best possible performance with the least impact. And as I said, if you are not using this kind of combination, there are still some alternatives which can provide you some mid-range performance, but it is our recommendation to use a combination of this sort to get the optimal performance from your storage configuration. Now, next on the storage configuration topic is, now that you have configured your storage correctly, which includes having the appropriate number of disks, then creating software RAID on top of it to ensure that you have appropriate IOPS from those volumes. You have configured the file system on top of it, and you have configured SQL Server to use that file system appropriately. Next is to ensure that this volume gets mounted correctly at the boot time. Now, one of the recommendations that we have for this is having a flag called no A time in the FS tab file or file system table file, which basically is what you would modify to ensure that the volume gets mounted at the boot time. This no A time option is somewhat similar to NTFS disable last access update option on the Windows ecosystem. Basically, what it does is it disables the operating system capability to maintain the last access time for a file. Basically, if the operating system has to continuously update the last access time for any database file, which is obviously going to be in heavy use constantly, that is a performance overhead or performance impact. And our recommendation is to use this flag, no A time, in the FS tab, which will basically disable this capability. And it has actually a relatively good performance. It can provide you with relatively good performance improvement. Now, I also want to mention one more thing, Now, this is very specific to persistent memory file system deployment. Now, today, the persistent memory deployments are not available on Azure VMs per se, but you can imagine that the VMs with persistent memory support will be available in Azure ecosystem in future, and the PMEM support or other PMEM is getting fairly ubiquitous in enterprise, at least high-end enterprise deployments. And it can provide you with performance improvement in certain configuration. So one of the recommendations for PMEM-based file system support is to ensure that the file system is appropriately configured, especially in the 2 MB extent size blocks, because that's what will enable certain features such as hybrid buffer pool or enlightened IO support, and SQL Server can make use of these features to provide you with performance improvement. Now, let's talk about the operating system itself. Now, so far we have already talked about the VM configuration, or choosing the right image, choosing the right VM size, and choosing the right storage configuration. Now, let's talk about what are the operating system configurations that you can configure in the Linux ecosystem to provide you with better performance. Now, Linux is it's an open source and highly configurable operating system, but that also means that you should know how to tune it and configure it appropriately to get the best performance out of this out of your deployment on Linux OS. Now, we have actually done quite a few performance validation, and we have documented quite a few of our operating system or kernel configuration best practices in an article, which is about performance best practices for SQL Server on Linux. Now, I'm going to mention few of the kernel or operating system configuration over here. As you can see, there are quite a few of these configurations, and I'm not going to go through them individually, but they can have a fairly large impact on performance. And I'll just mention a couple of them. There are a bunch of configuration under vm.dirty umbrella, and they essentially help lower the impact of SQL Server IO on the file system cache. So, and because SQL Server is trying to avoid file system and it's trying to write to the devices directly, but it can but operating system can still cache certain pages, and this particular configuration allows us to lower the impact of SQL Server on file system cache. So overall performance of the Linux deployment is better. The other option I would mention is, let's say, kernel.scheduling parameters, and there are quite a few parameters under this umbrella as well. Tuning these parameters correctly allows better scheduling of SQL Server threads for more timely execution of the network and storage IO stacks for SQL Server workload, and it improves the overall processing under completely fair scheduling algorithm, which improves the overall performance and throughput of SQL Server on Linux as well. There are a few other configurations as well, and you should actually take a look at them. Now, as you can see, there are quite a few of this configuration, and doing them manually each one at a time can be quite tedious. So to help you configure this in a better way, what we have done is we have created a profile that you can deploy using TuneD software. TuneD is a package available on all supported version of the Linux distribution, which is Red Hat Enterprise Linux, SUSE Enterprise Linux, and Ubuntu. It comes built into the Red Hat Enterprise Linux, but with Slash and Ubuntu, you may have to install it manually. But once you have installed TuneD, you can essentially take the profile that we have created for you and documented for you, and configure all these parameters at a single go with a single command. So it basically, what I want to say is that you should probably take a look at this performance best practices article, as you will find a certain amount of help to configure and tune your Linux operating system for a better SQL Server workload configuration. Okay, so now we have talked about the VM size, storage, and the operating system configuration. There are a couple more things that I wanted to briefly mention. One of the things is you should probably look at this option that SQL Server has made available to you via MS SQL Conf. It's called memory.memory_limit_ND. Now, the history of this is that in the Linux as an operating system, if there is an out of memory situation, Linux will essentially try to release some of the memory if necessary by killing a process. And the whole thing is called out of memory killer colloquially. I mean, it's a colloquial name, but it's well known as killer or out of memory killer. And to avoid getting into this out of memory situations, what SQL Server does is, by default, SQL Server uses only 80% of the physical memory available to ensure that enough memory is left behind for the operating system itself. While this is good, there is a side effect for a high-end configuration. So, for example, if you were to deploy SQL Server on a VM which has 1 terabyte of memory, SQL Server by default will only use approximately 800 GB worth of memory for its workload and will not use the rest 200 GB. Now, if you can configure and tune your operating system and all the required processes correctly, you might be able to bump that number from 800 GB to 900 GB or even more, if based on the kind of resource required by rest of the processes. And and this particular configuration allows SQL Server to use appropriate amount of memory based on the configuration that you choose. The other thing is about the CPU configuration. Now, by default, the Linux operating system, especially when it is deployed on Azure as a platform or in most configurations, chooses a more conservative power usage profile. And for SQL Server workload, you may want to use more power in a high throughput kind of a profile, so that CPU does not frequently step down on the kind of frequency, and so it doesn't have a variable performance if the CPU frequency has stepped down. So there are about 4 configurations that you can make at the kernel level, which will essentially help you configure your CPU power usage appropriately, so that SQL Server can stay at its peak performance through the workload. Now, as you can imagine, configuring all 4 options manually might be a little bit tedious. So the good thing is the first 3 parameters, which are in the green bar, they are configured appropriately when you use the TuneD profile that we have already I already talked about. So when you use TuneD profile, it configures the appropriate CPU frequency parameters so that it stays in more of a high performance profile throughout the workload, and it does not have a variable performance. There is one parameter, C state, that still has to be configured manually, and you should take a look at the documentation for your Linux operating system, which will tell you how you can configure C state appropriately. And our recommendation is that you choose C1 only, which basically means that it basically steps between idle and the full power, and does not vary quite a bit in between. Obviously, there is the last thing that you can configure is the network, and for this you should actually talk to your NIC vendor or network card vendor. Typically, there are quite a few parameters available to tune your network card or NIC card appropriately. And for example, let's say if your client and server are on the same fiber or on the same switch, and the switch as well as both client and the server machine can support jumbo frames correctly, then having jumbo frames enabled can give you better performance or better network throughput. On the other hand, if you have more devices or more switches in between in your network route or network path, then and if some of them may not support jumbo frames, then having jumbo frames enabled can cause TCP/IP fragmentation, and it can actually degrade network performance. So for this, you should consider your network administrator and ensure that you follow the NIC vendor's guidance for highest possible throughput. Now, I have talked about quite a few of these parameters that you can configure for getting good performance for your SQL Server on Linux deployment. And just to basically show you how good this performance can be, I wanted to or basically we ran some performance validation on VMs in Azure to show how good the performance can be. What we did is we chose a small size VM, which is basically 32 vCPU and 256 GB memory. For the storage, we used 4 P30 disks, and for the log drives, we used 2 P30 disks and striped them using MDADM, something I already talked about. We ran this test against both /12 SP5 and Red Hat Enterprise Linux 8.2. Both of which support FUA configuration. So as you can imagine, we configured the FUA parameters correctly. And then we just ran some performance workload against this. Now, this is not a performance benchmark, but just to get a fair idea of what this might look like in terms of performance validation, we use the same workload that we would use for TPCH benchmarking. So we ran the same performance workload against this configuration after configuring the performance best practices, as I already talked about. And as you can see, yeah, we got extremely consistent and extremely good throughput over an extended period of time. And and these are the client transactions. These are not the T-SQL level transactions, but these are actual client transactions. And we are processing somewhere between 700 to 800 transactions per second, as well as you can see on the IO side, both of these configurations were able to sustain somewhere around 30,000 read IOPS and 15 to 20,000 write IOPS consistently through the period. Now, this was able to sustain high level of IOPS is by the use of Azure Blob Cache, which is an improvement available on Managed Disk, and you should probably read about it. But Azure Blob Cache can help you process the read workload very efficiently. So with Azure Blob Cache and the kind of configuration that we did, we were able to sustain very high read IOPS as well as very high IO throughput in terms of 250 Mbps of read IOPS or MB per read IO and 100 MB per second of write IO. And as you can see, this was run over an extended period of time, and you can see that the throughput and the IO is consistent. So with that, all I want to say is that if you want to, if you basically deploy SQL Server on Linux platform in Azure, and if you configure it appropriately in terms of the VM sizing, in terms of your storage requirements, in terms of your operating system configuration, as well as all the storage configurations, you can get very high performance and high throughput for practically any kind of workload that you choose. Now let's talk about HADR for SQL Server on Linux in general. So there have been multiple options for HADR for SQL Server in general. The well-known alternatives being the failover cluster instance and always-on availability group. They are the most popular solutions. In the Windows ecosystem, they use the Windows failover clustering, but these solutions are also available in the Linux ecosystem. And in the case of Linux ecosystem, they use the Linux native clustering solution, which is called Pacemaker, and it's natively available on the operating systems. You can create failover cluster instances or always-on availability group with full high availability and disaster recovery solutions with the help of Pacemaker clusters. And SQL Server 2019 also introduced another availability group feature, which is called read scale replica. This one does not provide high availability, but it does provide disaster recovery and manual failover. And this does not require any kind of cluster type at all. And you can also deploy this in the Linux ecosystem. Additionally, there are multiple other clustering solutions available in the Linux ecosystem, considering it's an open source ecosystem. And SQL Server does support a few of these clustering solutions for high availability, and I'll demonstrate one of them and talk about another alternative as well. So now let's talk about the always-on availability group support in Azure VM. Now, the story goes that the pacemaker clusters were not supported in the Azure ecosystem until very recently. What we found is that the pacemaker clusters use certain component called StoreNet, and we'll talk about it in a brief time, which does not work very well in the Azure ecosystem, which means pacemaker clusters in Azure ecosystem could not provide the required availability time or uptime for the clusters which was required for SQL Server deployments. So the SQL Server product group worked with our partners, especially Red Hat and SUSE team, to bring the pacemaker cluster support for Azure VM type deployments. Now, the pacemaker clusters themselves are fully supported with high availability deployment in Azure IaaS or Azure VM environment. And SQL Server team has worked with this pacemaker cluster deployment to certify that SQL Server high availability solutions can also be deployed, especially the always-on availability group solution can be deployed in Azure VM environment. So now you have a parity in terms of being able to deploy high availability on premises and Azure with the same availability groups. Now let's talk briefly, about what I mean by this. So this is, a visual diagram of a pacemaker cluster, and you can think of these three nodes as this. These are the three VMs, and there are two services in a pacemaker cluster. The first is called CorosSync, which provides the clustering or the quorum management across the nodes. And there is another service called Pacemaker, which is which is known as more of a resource manager service, and that provides the resource management for resources such as SQL Server or virtual IP resource. Now, the most interesting or most critical part to support this kind of a pacemaker cluster solution in any deployment is what's known as a fencing agent resource. It's also considered a resource, and this is a resource provided by typically a hardware vendor, which basically allows a node to be rebooted if it's considered hung or unresponsive. So think of it this way, that assume that there are three nodes over here, and for whatever reason, the quorum decides, let's say node 1 and node 2 form the quorum, and it decides that the node 3 is unavailable or unresponsive. It would use fencing agent, which has a component called StoreNet, or which is used to reboot this node to bring it into a well-known or a good state. Now, the only problem with this solution is that the fencing agent typically needs to be made available by the hardware vendor or the ecosystem provider to reboot the system quickly. Unfortunately, this was not available on Azure ecosystem. So Azure VM could not be restarted quickly, which means the pacemaker clusters could not be deployed with high availability in Azure ecosystem. We worked with our partners such as Red Hat and SUSE to bring this fencing agent called Stoneit into the Azure ecosystem. So now that the picture remains same, you can deploy a fully configured pacemaker cluster with multiple nodes and SQL Server as well as the virtual IP resource. The virtual IP resource, which is being used for the always-on availability groups endpoint functionality. And there is a new fencing agent called the Fence Azure ARM. It's of type Stoneit. And this has been made available by working with our partners for SUSE and Red Hat pacemaker cluster today. And this allows capability to restart an Azure VM very, very quickly if pacemaker cluster decides that if that VM is unresponsive. So with this functionality being available in Azure now, you can deploy always-on availability group with AG endpoints and full high availability on a pacemaker cluster deployed on Red Hat Enterprise Linux or SUSE Enterprise Linux in Azure ecosystem today. And by the way, we are also working with Canonical to bring the same fencing agent and same pacemaker cluster support in Azure ecosystem as well. So soon you'll be able to deploy the pacemaker clusters with high availability on Ubuntu in Azure ecosystem as well. So now let's just take a quick demo of this. Now let me show you an example of configuring high availability or availability group on Linux pacemaker clusters in Azure. In this case, walking through the entire configuration steps would be unwieldy because it takes a while. So I'm just going to show you a fully prepared cluster. I'm going to show you a RHEL 8 cluster. In this case, I got 3 nodes of RHEL 8 or Red Hat Enterprise Linux 8, node 1, node 2, and node 3 in a same VNet. I have also created an Azure load balancer resource that I will talk about in a minute. And I have installed pacemaker cluster on top of it, enabled Stoneit agent, and also enabled or created an availability group on top of it. So let's just take a look at it as to what it looks like in SSMS or Management Studio. So for example, I'm connected to my node 1, and let's see what the node 1 looks like. I've got one database which is in availability group. Let's see what the availability group status looks like. So it has one availability group AG1, and it is currently in the secondary. The node 1 is currently a secondary replica. So let's take a look at what a node 2 looks like. And in this case, my node 2 is my primary replica. And node 1 and node 3 are my secondary replicas. I also have one database inside that and AG listener on top of it. The AG listener resource or AG listener definition looks something like this. It's basically a virtual IP address and a port number information that I have bounded. So let's see what that looks like in terms of the pacemaker resources. So I'm connected to my node 1 in this case, and I'm trying to show this the resources on the node 1. So as you can see, my cluster name is AZ or Azure HA cluster. It has 3 nodes, node 1, node 2, and node 3. I have configured the StoneIt agent of type Azure ARM fencing, and this is what allows us to be able to support this pacemaker cluster, RHEL pacemaker clusters in Azure going forward. As you can see, I have also created an availability group resource, AG cluster, and it has one master replica, which is on node 2, and two secondary replicas on node 1 and node 3. I have also a virtual IP resource associated with it, which is the same as my AG endpoint resource. So let's see what my resource configuration looks like. As we can see, my virtual IP resource is the same as my availability group endpoint resource. I also took the liberty of defining an easy to remember AG endpoint or DNS entry and bound it to this AG endpoint IP address, and I've connected to that using the AG endpoint as well. As you can see, right now I'm already connected to my primary replica, which is on node 2. Now, just to see what the resource movement looks like, you might remember that when you are moving resources for SQL Server availability group on a Linux cluster, you do not move the resources using tsql. You must use resources using the pacemaker command line. So in this case, this is the command line that I'm going to use. It's PCS resource move, and I'm asking the master resource for AG to be moved to node 1, and then do appropriate cleanup on top of it. So let's see, how that goes. So I'm asking the resource to move to node 1. So let's see if I can connect to node 1 and see if the resources are moving to this as. And as you can see, my node 1 has already become primary. So let's see if my AG endpoint functionality is also working fine. I'm connected to my AG endpoint, and let's see if I can refresh my availability group resource over here. Obviously, in the background, it has to reconnect. So it might take a few seconds for it to reconnect. On the Linux side, okay, and as you can see, it's already connected to my primary replica, where node 1 is my primary replica. Okay, so as you can see, we can easily move resources using PCS resource move command. Now let's try to see if we can test the fencing functionality. Now, fencing functionality is what's newly available. We worked with the Red Hat team to create Azure ARM-based fencing agent, and this is what gives the StoneIt agent or pacemaker cluster the information about what type of resources these nodes represent, the node 1, node 2, and node 3, that they are Azure VM, and how to reboot this VM so that they can be brought into clean status according to pacemaker cluster. That's how pacemaker cluster understands and manages the resources if it deems any of the resources to be dirty. So now we know that node 1 is my master and node 2 and node 3 are my secondary replicas. Just to see test what it looks like, let me just fence my node 1, and essentially, when I'm saying I'm testing my node 1, this is essentially a test command. This is telling pacemaker cluster to assume that a node 1 is not clean. Now, since I'm executing it from node 1, what pacemaker cluster will do is essentially it will reboot node 1. It will assume node 1 to be unhealthy, and it will essentially reboot node 1. So I'm moving to node 2 in this case and executing the status to see what the current status looks like. And as we can see, it's saying that it's promoting node 2 because it has already stopped node 1, and it is keeping node 3 as my secondary replica. So it takes a few seconds for it to promote the replica. And as you can see, it says it has already started the resources on node 2 as its primary replica. So now let's see if I'm connected to my AG endpoint, and let me see if I can refresh my resources and get the updated status. And in this case, once again, I can see that my node 1 is unclean and it is in rebooting state, so it shows as disconnected. Node 2 has already become my primary replica, while node 3 is my secondary replica. So now, with new pacemaker or Stony agent being available for pacemaker clusters for Linux VMs in Azure, you can create high availability based configuration, availability group environments for SQL Server high availability in Azure as well. And what I just showed you is a pacemaker cluster, 3-node pacemaker cluster using Red Hat Enterprise Linux. But SUSE Enterprise Linux also supports pacemaker clusters with appropriate Stony sensing agent. For example, this is my second cluster that I have created. It is based on SUSE Enterprise Linux, and it's currently connected to my primary replica, which is on node 1. So if I go ahead and connect to this node and find the server name, it says my server name is sln1 or /node 1. And if I see my version name, it should give me SQL Server 2019, which is on SUSE Enterprise Linux. So as you can see, it is saying that it is SQL Server 2019 on SUSE Enterprise Linux. So as you can see, you can create pacemaker clusters with full high availability and fencing functionality, and you can create SQL Server high availability configurations as in availability groups on top of this pacemaker clusters in Azure. How can we monitor or configure the pacemaker cluster itself? And now this is not really necessarily a SQL Server topic. What I can say is that most of this Linux distribution tend to have some sort of a UI support for managing and monitoring pacemaker clusters. For example, in case of Red Hat Enterprise pacemaker clusters, there is high availability management, what's also called PCF UI, and you can simply connect to this using your HA username and password, and then it allows you to understand what's going on in terms of the resources, the nodes, and it allows you to do the most of the configuration as well. For example, in this case, it shows me what's running on each individual node. It shows me what resources I have available and the attribute of each of the resources. And it allows me to do the fancy configuration as well. Now, just like Red Hat has pacemaker, the UI pacemaker configuration and monitoring tool in PCS UI, SUSE team also has something similar. It's called SUSE Hawk, and that provides very similar functionality as well. As you can see, I'm logged into the pacemaker cluster for SUSE pacemaker cluster that I had shown earlier here. This is my pacemaker cluster on SUSE Linux, and I have one availability group with multiple replica on top of it, and the UI over here allows me to see the resources, which is my primary replica. It shows me, it's a pretty decent dashboard, which allows me to monitor the configuration and, do appropriate editing of the configuration, constraints, and fencing, etc. So if you explore a little bit about pacemaker UI support for most of this Linux distribution, you'll find that you have some level of support which will allow you to be very productive very quickly for managing your pacemaker clusters. Now let's quickly go over the steps required to configure pacemaker cluster and SQL high availability on both RHEL and /VMs in Azure. Now, basically, I have sort of divided all of this into 9 different distinct tabs. And at the first glance, it may look a little daunting, but at the same time, what we have to remember is most of these steps are actually one-time steps, and you do not need to repeat them. I also color-coded steps a little bit in terms of the gold steps are typically configured by system administrators, while the blue steps tend to be configured by database administrators in most cases. So let's just briefly talk through them. The first steps are typically creating appropriate resources, which means creating resource group, availability set, virtual machines, and configuring high availability and pacemaker cluster between all the necessary VMs. Then the next step is typically configuring the STONIT device for fencing, which is what we talked about earlier, that we need to configure a STONIT device for fencing to make to get pacemaker cluster in a supported state. And all of this should ideally be configured by a system administrator. The next steps are typically the installation of SQL Server tools and the HA configuration agent, including configuring the necessary availability group endpoints for communication. And then after which the steps are basically configuration of SQL Server availability group and necessary resources in the pacemaker cluster. As I said, it might appear daunting at first, but to be honest, up to this point are essentially all the basically one-time steps. All these steps would be essentially one-time steps. And the steps configured over here are what you do for each availability group when you decide to configure them. We have already documented our instruction set on how to configure a pacemaker cluster and availability group on Red Hat Enterprise Linux. The detailed instruction for SUSE Enterprise Linux are to be published soon. They are currently being audited and reviewed. And we are working with Canonical to bring pacemaker cluster support for Azure VMs, including the fencing support. And I have pasted a link over here. And soon enough, the pacemaker clusters will be supported on Ubuntu distribution on Azure as well. Okay, so until now, we have talked about pacemaker clusters as a clustering solution on Linux as a platform, which supports SQL Server availability groups and federal cluster instances on Linux platform, and always an availability group on Azure as a platform. Now, the one thing which is very interesting is that Linux being open source platform, it has quite a few alternatives for the clustering technology, and you're not limited to the pacemaker clustering technology technology per se. Now, one of the, I just want to mention a couple of different other clustering softwares which can show you alternative, although I'm pretty sure there are additional alternatives available in the wild. The first alternative, the clustering alternative that I want to mention, which is available on Linux as a platform for SQL Server, is called DX Enterprise by DH2I Software. It is basically an alternative to Windows failover cluster or a pacemaker. This particular piece of software, the DX Enterprise, actually allows you to create clusters across Windows and Linux as a platform, as well as on containers as well. It enables you cross-platform and cross-distribution clusters, and it also enables you to create Azure AG replica benefit, because you can have your primary replicas on premises and secondary replicas on Azure, or vice versa, if you want to create some sort of a HADR scenario, a geographically distributed HADR scenario. Of course, this software also provides failover cluster instances as well. And the DX Enterprise software is a pretty good alternative for you to consider if you are, especially if you're choosing Linux as a platform, considering the kind of scenarios it can enable you with Windows and containers as well. So for this demonstration, I am going to use three VMs. This is my Windows VM, Windows 10 VM, which also has a SQL Server installed on it. I also have two other Linux VMs. This one is a Ubuntu VM, which is my Node 1, and this one is my Red Hat VM, which is Node 2. And I have already created a DH2I cluster on top of it, to save some time in the demonstration, although it took me no more than 15 minutes to create the entire cluster across all three different nodes. So let's see what that looks like. When I look at it from the DX admin interface. The DX Enterprise software also comes with this DX admin UI interface, which is very helpful in creating and managing your DH2I clusters. So in this case, first, let's take a look at the cluster itself. The DH2I cluster in this case has three nodes. One is the Windows node. Let's see the information there. So this is my first node, which is Windows 10 node. My second node of the DH2I cluster is okay. It's a Ubuntu VM, Ubuntu 18.04 VM, which is part of my DH2I cluster. And third node of my DH2I cluster in this case is a Red Hat Enterprise Linux VM, as you can see. Now, from the flow perspective, the next step, once the DH2I cluster is configured, the next step to configure is obviously to configure it from the SQL Server perspective. And from that perspective, the next step, what you do is create a vhost, which is an equivalent of virtual server for failover cluster instances, or always on availability group endpoint in case of AG scenario. I already created one of these AGs, so I'll just show you that first, and then I'll walk you through how to create one. So in this case, as you can see, I got a two-node cluster, the AG. One is a Ubuntu node. Second is the first node is the Ubuntu node. The second node is the RHEL node. I have created an AG on top of it, which basically is, this UI shows me the configuration of AG. It shows that my primary node is currently Ubuntu node, and secondary is the Red Hat node, and my AG configuration is a synchronous commit configuration. The seeding mode is automatic, and current situation is connected, as well as it tells me the actual database name and the current state of the database. It's a pretty nice UI from the management and monitoring perspective. So from the SQL Server side, if you wanted to see this, it looks like just any other, availability group in this case. So as we know, in this case, the primary node was on, let's say, the the rel scenario. So we'll just, or rather the rel node. Actually, it's on Ubuntu node. So we'll just go with that and see. It says, now my primary replica is my Ubuntu replica, and my secondary replica is the Red Hat replica. The availability database is AdventureWorks 2017, and the listener is also created, and the listener the configuration is also what we already saw earlier in the DX admin interface. And as you can see, it's very, very simple to create and manage availability groups with DX admin interface. Now, let's say right now my primary replica is on Ubuntu, right? So what if I wanted to initiate a failover? And the DX admin UI interface also provides me capability to do that. I can simply choose the node that I want to make primary and simply say start hosting on that node. And the UI interface has enough intelligence to understand how to go about doing that. And as you can see, now it says that my primary node is now the Red Hat node, and secondary node is the Ubuntu node. So let's see, if the failover has occurred properly on the SQL Server side. And as we can see, if I refresh over here, now it says my AG is AG1 is secondary, and my the Red Hat node, which was secondary earlier, is now my primary replica. Primary replica. So this basically enable the DX admin UI interface enables you to create and manage the availability groups or failover cluster instances very easily for a DH2I cluster. I just want to mention another solution, a clustering solution available on Linux as an ecosystem, which supports always-on availability group from SQL Server. It's called HP Service Card for Linux. Due to lack of time today, I won't be able to demonstrate the functionality over here, but I have pasted a link over here, which should take you to a demonstration published by HPE team. And this is while this does not support Azure as a deployment target today, it is an alternative for on-premise deployment for Linux ecosystem. So I just wanted to mention this as an alternative to you in case you are interested in exploring clustering solutions, third-party clustering solutions in Linux ecosystem. So to round up this session, I want to basically summarize what we have talked about. SQL Server on Linux is highly performant and highly functional engine, which has basic and advanced OLTP features, as well as advanced data warehousing features, including access to the heterogeneous data sources with poly-based functionality. SQL Server on Linux includes advanced security features and advanced high availability features, including always-on availability group. You can deploy SQL Server on Linux in Azure very quickly using the built-in images or automated shell scripts. You can deploy SQL Server on Linux with high performance configurations as well as high availability to match your enterprise requirements. To essentially summarize, if you are considering use of SQL Server on Linux as an ecosystem, Azure platform should be your first choice, as it provides you everything you might need in terms of meeting your functional requirements as well as performance and high availability requirements. With that, I want to close the session and say thank you very much for your time. We really appreciate this, and we have really enjoyed presenting this session to you. And please feel free to reach out to us if you have any other questions.